To use a calculator to figure out to solve a trig equation, we're going to use the inverse sine or inverse cosine or whatever feature to get our first solution. And so if my equation is the sine of theta equals 0.3, I will use the inverse sine, second sine, to figure out what angle this is. So make sure your calculator is in radian mode. We want our answers in radians. And when you type in inverse sine of 0.3, you get your first answer of approximately 0.03 radians. Now, it's a total coincidence that those ended up being the same value, so just don't think that that's always going to be the case, but there's one solution. And now one thing that's important to note when you use your calculator is that that pi had already been multiplied into your answer, so do not add a pi symbol to the end of these like we've been doing for some of our other problems. The pi is already in there, so it's just 0.3 radians. Now, as I said, that's one solution. We need to find the other solution, and if you've watched our previous video, you know that this is all based on this STC thing. There's two quadrants where sine is positive. So we found one angle, and that's actually in quadrant 1. There's a second angle, or a second quadrant where sine is positive, and that's going to be in quadrant 2. And so to find this, well, I'm going to think of what I found is really a reference angle. That's really what it is. And so in quadrant 2, that reference angle is going to be 0.3 between the x-axis. And then to measure this, just like we've done in our other videos, I want to measure that angle from the positive x-axis counterclockwise. Well, as we've done before, we know that halfway around the circle is 1 pi. And so to figure out this missing angle over here, I'm going to do 1 pi minus 0.3. Now, when you do this, do these in class, we usually just did 1. We didn't type in the pi. Since the pi is already multiplied in there, you actually have to use pi, or about 3.14 minus 0.3. So just watch out for that. You do have to use the actual pi for this subtraction. And so that angle comes out to be approximately 2.84 radians. And again, the pi has already been multiplied into that. I would recommend you check these, and so they're really easy to check. Just do the sine of 0.3. That should come out to be about 0.3. Maybe a little bit off because of how we rounded. And then also do the sine of 2.84 and make sure that also comes out to be about 0.3. So that's a really basic one. Watch how these can get a little more complicated though as we try these next two. So again, I'll start this second part the same way as the first one. I'll do the inverse tangent of negative 0.25. And again, make sure you're in radian mode, otherwise this isn't going to work. Make sure you're doing second tangent to do the inverse tangent on a calculator. And so that angle comes out to be approximately negative 0.24. And again, it's a coincidence that those ended up being so close. Now this time though, last time that was one of our answers. This time it's not. The reason that this is not one of the answers is because remember, we're going to agree that all of our answers need to be between 0 and 2 pi, or 0 and 6.28. That's what 2 pi is approximately equal to. And so a negative value doesn't fit in there. Negative is less than 0, and so that cannot be a solution. However, as we've done in our previous video, think of that as really a reference angle. And so to answer this question, to find the two answers, I need to think about what two quadrants is tangent negative in, since we're working with a negative ratio right here. Well, the two quadrants where tangent's negative is going to be quadrant 2 and quadrant 4 are the two quadrants where that's negative. And so I'm going to go ahead and add in my reference angle then between the angle and the x-axis. And I no longer care that it's negative. The reference angle is just what is that angle between the x-axis. So 0.24, and I'll have to remeasure. And then down here also 0.24, and I'll have to measure around again clockwise going in that direction. So we've already talked about how to find this in quadrant 2. Just do 1 pi, and you do need to use the pi, minus 0.24. And so this first angle comes out to be about 2.90. We would never find that on a calculator. Our calculator will only ever give us this negative 0.24 value, and so I have to do this part by hand. I can check it though using a calculator, do the tangent of 2.94, and you'll see you do get a reference angle of about negative 0.25. For my second answer, I haven't quite gone a full revolution. So a full revolution would have been 2 pi. I've gone a little bit less than that, so 2 pi minus 0.24. And again, you do have to use the pi for these problems. And so that comes out to be approximately 6.03, which again, that is in our domain. So these are the two answers we want to use. These are the two answers that are between 0 and 2 pi, or 0 and 6.28. The negative 0.24 wasn't. So, as you can see, they get a little more involved, and then watch this last one, because this last one even has one more trick to it. So, start out the same way as the other ones have started. Let's do the inverse cosine of negative 0.80, and so I get an angle of approximately 2.50. And so again, the question is, can I circle that? Is that one of the answers? Well, yeah, 0 is between or 2.5 is between 0 and 6.28. So fine, that is an answer. The trick, the harder part of this problem comes up when you try to find your second answer. And the reason is, well, it's not necessarily obvious until you start to think about what's happening. I would want to draw that as a reference angle, but if I think about what this angle looks like, recall what your quadrantal angles were. That was pi over 2, that was pi, this was 3 pi over 2, remember all that. So if I convert these into decimals, though, since this problem is all about decimal approximations, pi over 2 is approximately 1.57. Pi we know is approximately 3.14, and so if I think about where 2.5 radians would be, it's between 1.57 and 3.14, and so that's the angle that I'm looking at, which means it's obtuse. And so if I say, well fine, try to draw that obtuse angle in the other quadrant where cosine is positive, how are you going to do that? You can't draw an obtuse angle in a quadrant. And so there's one extra step we need to do for this problem, and that's actually to find out what this little reference angle is right here. So I know that this angle is 2.50 approximately. If I subtract that from pi, I find out that this reference angle is 0.64, and so that's the reference angle. That's not an answer. I guess I shouldn't circle it. That's the reference angle that I can go ahead and draw in the other quadrant where cosine is going to be negative. And so thinking back to, again, STC, the other quadrant where cosine is negative, I already have it in quadrant 2 where cosine is negative. The other quadrant where cosine is negative is going to be quadrant 3. So I can finally finish this by taking that reference angle of 0.64, which would be right there, and then measuring all the way around this way, which would be taking pi and adding 0.64 to it to get my second answer after all this work. I get a second answer of approximately 3.78. And again, I would definitely check these because they can get a little complicated, as you saw. And so to check this one, just take your original problem, which was cosine of theta. So I would do cosine of 3.78 and just confirm that on a calculator it does come out to be approximately negative 0.80.